Aloha class, here we go. Judgment Week Ban. Let's see how you guys are doing. Remember, just like 1 and 2, print this guy out, do your solutions, dominate the bad boy, take a peek, and then send it to me and let's see how you did. And then look at the solution, see how you're doing, all right? By now, right, we want to be getting 6, 7, 8s on these bad boys. So let's see how you guys did on this one. But remember, not till after you've done all that and see if you could get it done in under 20 minutes. Okay, that'd be a good idea of where you stand, all right, in terms of being ready for this bad boy. All right, since you've done all that stuff and you've sent me your video, let's go. All right, so we have this graph, f of x equals -2 natural log of x. Now, the interesting here is it says it's from 0 to 1. We go to 0, and the interesting thing is it never gets to 0. Okay, so this is going to be kind of improper here. And we have to make sure we adjust and we account for that, especially because this very well could be an area volume question, which incorporates some of our BC topics. Okay, it says find the area of the region if it exists, if it does not explain why. Remember, that if it does not explain why, they probably want students that aren't sure what they are doing to say, hey, this is why I can't do it because it never reaches 0. But we can do it, right? We can do it with the limits. And doing it kind of like an improper integral. So here we go. Area for this would just be top minus bottom, top minus bottom, top minus bottom. So we would go ahead and we would do the integral, right? And we would go from 0 to 1. But the important thing here is that 0 thing, and we're going to adjust that here in a brief moment, okay? Because that should be an issue. I'm bringing the -2 on the outside because that's a constant, because it would just be top minus bottom. The bottom would be 0, and that's it. Okay, so that's kind of how we're going to start that problem. But remember, this is an improper integral. Why? Because 0 is no good. Okay, 0 is no good, right? The natural log of 0, what? Can't do that. So what are we going to do then? -2 is a constant, remember? And this is when we're going to do a limit as b approaches 0, but we're going to approach 0 from the right. Remember, it's been a while since we've done these, so I'm really glad this teacher made up these problems. Okay, and we get that bad boy right there. Okay, so now we're going to have to do an antiderivative. And believe it or not, we've done that antiderivative in the class. This might be one you want to maybe have memorized. But that actually is integration by parts, where our u is going to be the natural log of x, lipit, right, log, and then my dv is just dx, okay? And so my derivative, remember, is 1 over x, okay? And then this one here would be an antiderivative of 1 dx would just be x. So remember, we backwards zero that thing, and we got, that's the original problem, which is equal to these two guys. Okay, so how am I going to write that? So that'd be equal to -2. We got the limit as b approaches 0 from the right. Okay, and it's going to be equal to these two guys. So it'd be equal to, let me just go x natural log of x. And we still have to evaluate that from b to 1. But then we minus the integral from b to 1 of these two guys. And that's x times 1 over x, which just would be ichi dx. That's it. Okay, so that's actually all you have to be able to do to get this problem correct. So it'd be -2, the limit as b approaches 0 from the right-hand side of, I'm going to plug in the 1 and the 0 here. I'm going to actually do this work to simplify it. So that'd be 1, right? 1 times the natural log of 1, which would be 0. Okay, now I'm going to plug in, I'm not plugging in a 0, sorry, I'm plugging in a b, right? And then it's going to be minus b times the natural log of b. Remember, it's not really a 0, okay? And then I still have to do this piece right here, which is minus, what is the antiderivative of 1? Well, that's just x, and then I'm going to evaluate that from b to 1. Okay, so I have to do even more work. Sorry, I'm going to have to come down here. Hopefully you guys can see it okay. Hopefully you can already notice that you're going to put a 0 in for that b, which would cancel out that right there. It'd be the natural log of 0, but 0 approaching from the right. But it wouldn't matter because it would be 0 times something, okay? And then we still have to do this piece right here, which would be plugging in a 1. But then remember, it's going to be subtracting a -b. So it's going to be plus b. Okay, and after all, what do we put in for all that stuff? We put zeros in for all those. So that guy's going to be 0 because it's 0 times something. That's going to be 0. So it looks like we just have the -2 left and a -1 left. And what's -2 times -1, class? Niban. Okay, and you would get 2 as your answer. that would be a lot of points. Okay, and I even want to break down this a little bit because I went by it a little fast. But you would have this little piece right here, okay, where you would have, 0, I'm sorry, 0 from the right. It should be a b. Okay, 0 from the right of negative b natural log b. Okay, and the interesting thing about that is I could rewrite this problem if I wanted to be the limit as b approaches 0 from the right of, I'm going to rewrite this as the natural log of b over, right? It's going to be negative. Let's just bring the negative on the outside so we don't have to worry about it. I'm going to put just 1 over b on the bottom. So it's kind of like I have a top and a bottom. Does that kind of make sense, class? And then if you plug in a 0, you get, kind of get indeterminate, right? Kind of like a 0 over 0 or something. It's just very indeterminate going on right there. Okay, and we can always use L'Hopital's rule to help us out in this type of a situation. Okay, which would be the limit. Now, would the AP expect you to do all of this? I don't think so, but you know what? You never know. The derivative of the natural log of b would be 1 over b all over, okay, the limit as b approaches 0 from the right. And then that would be b to the negative 1, which would be negative b to the negative 2. And then, believe it or not, there's some major simplifying you could do right there, right, class? This would be like a b squared, right? This negative and this negative could kind of cancel themselves out. And then that we could bring upstairs, and it would be like b squared times 1 over b, which would just be b. And then that would be the limit of all of that stuff. Right now, you can plug a 0 into just that b, which would be 0. I know that was a lot to take in. I don't know. I don't think the AP would make you go that crazy on that. If I really lost you, we actually did that in class one time way back in the day. If I lost you, then let's Google Meet it. All right, here we go. Now we're going to revolve this guy about the y-axis. Spling. So if I wanted to draw it, right, that would be a disk method. But once again, the interesting thing is this dude goes on forever and ever because it never reaches. So once again, I'm dealing with this infinity guy, right? Because it's going to be pi r squared, but it's going to be pi. We're going to bring that on the outside from 0 to infinity, right? Goes on forever. Once again, it's improper. Okay, and then what do we go here? We go with the little, oh, snap. It's a dy problem, right? We're going to square it, right? Because we need to know what the radius is, and it's a dy problem. So what I need to make sure I do is come over here over to the side, and I need to solve for x. Let's go ahead and divide by that negative 2, turn it to an exponential, and it'd be e to the negative y over 2. So there we go. So it'd be e to the negative y over 2. Okay, that's nice. Now, once again, we're going to have to turn this into a improper integral. Okay, I probably should use c this time. Okay, I'm going to use c from 0 to c. If I bring that 2 in there, it's just going to be e to the negative y dy. How about that? And then that ends up turning into a very nice antiderivative, right? Antiderivative of that would be negative e to the negative y, 0 to c. Let's plug in our stuff now. Still got to evaluate it as a limit. And then what do I get here? I get a negative e to the negative c minus e to the 0, which would be e. Okay, now this, right, was going to be 0 because it's going to be 1 over e to the c, 1 over infinity 0. So you get your negative 1 right there, right? And we have our pi on the outside. I think I made a mistake here with just one regard, is that's negative. So that's actually going to be a positive, right? Because you're going to plug, so you plug in the c, and then it's minus a negative, which would be positive. And so I end up with just a pi and a positive 1, which would be pi. Okay, and then you would have gotten that all right. Okay, and both of these were pretty intense. I would say the first part might be worth four points, and it says here in my notes that they do make you do L'Hopital's rule. They don't really show it much in there in these notes that I have or in the solution guide, but it does have showing L'Hopital's rule for that one piece. So let's meet at Google Meets and let's talk about that a little bit more this week if I lost you a little bit on it, okay? And then part B would be worth 3 points. All right, let's go to part C here. Part C here, okay, we're dealing with cross sections now. A rectangle, but we're starting at 0.5, which is nice. They're giving me a break from dealing with this improper integral stuff. but it says, there we go. So we have rectangles where the base is on there, but the height protrudes out at 4 times. Okay, so then this is just going to be the area of a cross section. That's it to find the volume. So we're going to be the integral. Oh, and we don't even have to solve it. Okay, from 0.5 to 1. Okay, the base of these guys is just the function, right? But then the height is going to be 4 times the base. Right? That's not bad. Nice and easy. Japanese. That's nice after the first one was so tough. That'd be 16. I would pull the 16 on the outside. And I've got a couple of those natural logs. Booyah! Right? Not bad. That probably, it says here that was worth a point. Come on. That would be worth more than a point, you guys. Okay? All right. And then we got part D. Right? Perimeter. Second time here in the past couple of weeks where we've done with perimeter, which will be dealing with arc length. But it's for that region you just did. So what is that? What is that? And what is that? So hopefully it was good practice, this one. This one, nice and easy, right? That's just 0.5 to 1, so it'd be 0.5. Okay, plus, what is this length right here? Well, that's just the curve, top minus bottom, right, at 0.5. So that's simply going to be -2 natural log of 0.5. Right? That's going to give me that distance. And the last is we're going to use arc length for that. Do we remember what arc length is? It's from 0.5 to 1 because that's what we're traveling, right? Of the square root of 1 plus, remember, the derivative squared. Okay, so what's the derivative of that? Well, shoot, that's kind of nice too. Boom. Dunzo! And I don't think you'd have to simplify. Here in his little notes here, he's going to have it simplified, you guys. But I don't really think you'd have to simplify anything, okay? But that's it. All right, that's question 3. Let me go ahead and give you guys what the solutions with the points. Remember, this is some teacher. He is like an AP guru, I hear. But there's a couple ways of doing it. If you look at part A, he gave another solution of turning it into y's and going a little right minus left, which he's not treating these as improper integrals with the limit. You would definitely have to do that. Okay, he didn't do that. So even though he's a guru, I don't know, shame on you. He didn't do the limit for part B either. And you guys, you would have to do that. Okay, that's a BC topic where we do the limits. Remember, if it's an infinity or if we don't quite reach it, like we didn't reach 0 before. Okay, but I kind of like if you turned it into y's. I think it made the math definitely easier for that one, and you wouldn't have to do LHOP for that one. Okay. And let's talk about these. Meet us at Google Meets, and we'll do it the other way too. Alohas!